Greetings and welcome once again to the new Calculus channel. My name is John Gabriel. So, for a long time, uh, Britannica has been wrong about many different concepts. And we're going to look at one concept which I've spoken a lot about in the past and review the whole entry, pointing out where the entry is wrong and bearing in mind these 3 points that I've outlined over here. So, for example, all knowledge is questionable. No knowledge is ever past further investigation. And all knowledge is subject to correction and revision. Okay, those are the main parts, right? There is no such thing as established knowledge. That's just mainstream garbage, total mainstream garbage. So, what does the entry say? Let's see. So, here's the entry, and it says, excuse me, the mean value theorem in mathematical analysis. Actually, it has nothing to do with an analysis. So that's the first mistake. Nothing. Oh, I hate it when it gives me a big one. Nothing to do with analysis. Absolutely zero, by the way. Absolutely zero. And the fact that there's so much crap on it in the mainstream actually proves that they didn't understand it. Okay. They've got fantastic hand waving proof. It's not really a proof, but anyway, and a lot of circular arguments, a lot of statements which are absolute BS. So it says uh, dealing with a type of average useful for approximations. Excuse me, what is a type of average? That's absolute garbage. It's not a type of average. It's dealing with nothing but a level magnitude, nothing else. And you know what you call this in the mainstream? You call it an arithmetic mean. Okay. And arithmetic mean is a misnomer, as you all know, because it has nothing to do with the middle of anything or relative position. So, two incorrect statements already. How is it useful for approximations? It's got nothing to do with approximations. So that whole statement, three up till here, three flawed claims, and then it says, and for establishing other theorems such as a fundamental. Now that part is right, and for establishing other theorems, but the fundamental theorem of calculus is not an other theorem; it is the mean value theorem, and I've shown you that, so I'm not going to go over it again. So, three mistakes in this first paragraph. Okay, then. The theorem states that the slope of a line connecting any 2 points on a smooth curve. And now notice the bumbling idiots on Wikipedia. If you type in fundamental theorem of calculus and you go to Wikipedia, let's see what they say. The incorrigible apes think it doesn't have to be smooth. They believe over here that it only needs to be continuous. But of course, I mean, what can you expect from orangutans, right? I mean, what do they know? They're idiots. Okay, so they don't know anything. And if you read this article carefully, you'll see that it says only continuity is required. And I'm trying to find it now somewhere. Okay, it's somewhere in here, but I suppose what you could do is you could go back up here and you could say continue. And then that's the first one. I don't want to go through all of them. So if I don't find it quick, continuous real valued function. Absolute garbage. I mean, it must be smooth. Okay, so this is just total rot. Just shows you, I mean, that every mainstream academic you speak to has a different idea, which means all of the ideas are wrong and they're all morons. So it says that the slope of a line connecting is the same as the slope of some tangent line to a curve at a point between the 2 points. It doesn't say that. So let's see. What they're saying there is that the mean value theorem says that the slope of a curve, so let's get that right, connecting any 2 points. So we take any 2 points, let's say this one and this one, we connect them like that. And it says that is the same as the slope of some tangent between the 2 points. Okay. Bah. That is unremarkable and a property of every smooth curve. Any smooth curve will have this property. Why? Because if we go back to Thales, who lived thousands of years ago in ancient Greece, he established that if you have a line like this and a line like that, and you draw any line parallel to this line, okay, like that, and you join these lines, then this will be in proportion to this side, and this will be in proportion to this side. In other words, any parallel line will still preserve the proportionality, which means essentially that what you can do is that you can take any line and divide it into n equal parts. Okay, how do you do that? You just make sure that you place the parallel lines at equal distance, and that can all be done with a straight edge and a divider. Okay, so very easy. And then 2,300 years ago, they could already prove, even without the concept of number, that the slope, that any given slope that you find here has the same slope as a tangent line. And how did they know? Because they didn't know, but I'm telling you, and I know. So if you have, for example, lots of slopes in this, you do have lots of slopes, okay? And they represent some other smooth function. Let's say a function like this, right? Whatever. And it's saying that all these y-ordinates can be redistributed so that they're all equal. And one of these slopes will be equal to the slope of this line, okay? That's all that it's saying. And Thales, using only the theory of Thales, we can show that we take the shortest of all these lines, the shortest, and then with a divider, we cut, and we don't have to take infinitely many, just take a few, because I'll show you that the so-called infinitely many thing doesn't really matter. So if you take a few, you can cut off the extras, join them up in one line like that, divide them into the number of lines you have, and then you have the level magnitude, or what's called the arithmetic mean, which you simply add to the lines where, except for the shortest line, to the lines where, and also the shortest line, but to the lines where you removed the parts off. So you do it to all of them except the one which has only that length, okay, is the shortest, in other words. So without any numbers, without any real numbers, we don't even touch real numbers, don't even talk about any analysis or anything like that. And so in other words, it says at some point the slope of the curve must equal its average slope. Average slope is another mistake. What does average slope mean? So average slope means level magnitude, okay? So they're talking about level magnitude, but average slope doesn't tell you anything. That's why you don't understand what the heck is average slope. And if you look at the figure, I mean, it doesn't tell you anything about average slope. All it says is that these two slopes are the same. And if they had any smarts, they would put parallel, a sign here denoting that these lines are parallel, okay? So up to here, we've noticed a lot of mistakes all the way up to here, okay? And then it says, in symbols, if the function fx represents a curve, a and b are the two endpoints, and c the point between, then f prime of c represents the slope of the tangent line at c as given by the derivative. Totally unremarkable. It represents the level magnitude, like I showed you here, okay? It represents the line that would represent all the lines in the interval if they were all made equal to redistribution. That's the only time you can talk about a level magnitude. Otherwise, you can't even begin to talk about an arithmetic mean, and I'm using those interchangeably. So that's what it means. So up to there, totally incorrect. And then the final paragraph says, although the mean value theorem seemed obvious geometrically, I don't know how it seemed obvious to them because they never understood it. That to me is a mystery. Proving the result without appeal to diagrams involved a deep examination of the properties of real numbers and continuous functions. There are so many errors in this paragraph, and I've already outlined some of them. First of all, Functions need to be smooth. There's no such thing as a real number. In fact, you don't even have to know anything about numbers, never mind real numbers. And this is one of the typical hand-waving arguments where they throw their hands in there, using terminology that might intimidate fools, because most people are fools. And finally, other mean value theorems can be obtained from this basic one by letting f of x be some special function. That's absolutely laughable. There's only one mean value theorem, and it's a theorem that says that f of b minus f of a is equal to f prime of c. Okay, that's the only mean value theorem. And it shouldn't be called the mean value theorem. In fact, I even propose that this should be called the level magnitude theorem. Okay, level magnitude theorem. So as we've seen here, the Britannica entry is wrong in every paragraph, and in some places so many flaws that it's hard to write down all the mistakes. So what is the message behind this video? Well, the message is this: all knowledge is questionable. All knowledge. There's no knowledge that has a privilege not to be questioned. And then no knowledge is ever past further investigation. That almost sounds like the first one, but it contains the first one. What it means is that even if it looks like it's correct, you can still investigate further. And the last one says that all knowledge is subject to correction and revision. And I have just explained what could be correction and revision to this garbage entry posted on Britannica about the so-called mean value. What the heck is a mean value? It doesn't even begin to make sense, okay? So if you said level magnitude, then yeah, people would know it's this. And so early on I mentioned that the number of lines doesn't matter. Yes, that is proved in my in this video, and also a link I will place to an article, okay? So this one here, which is mainstream mathematics academics have never understood the mean value theorem. So if we open that one, this is the link. I think this should go to the article. Let's just see. Yes, it's this one here. So I'm going to place a link this in the details section so you can see why this is the fundamental theorem of calculus, what it means and how it should be correctly stated. And by studying these things, you will understand that calculus works because of valid reasons, not because of bullshit like infinity, infinitesimals, and limits, the circular rot of limit theory. It's all garbage, okay? Calculus is 100% geometrical. Even line integrals, even surface integrals, even Green's theorem, even vector divergence theorems, all of those, anything in calculus that deals with integration links to the fundamental theorem, which is the level magnitude theorem, which is the level magnitude theorem. Okay, so this is probably the last time I shall ever speak about this, because I've covered it in so many ways. A proof that the number of lines here doesn't matter is given in my article, and if it doesn't contain the full proof, you will find 3 different proofs in my ebook, to which I'll also place a link. If you're not already a subscriber, become a subscriber and tell your friends about it. Also, follow me on Academia.edu. I'll place a link to that. And if you're feeling generous, buy me a cup of coffee or a meal. You can contribute at a GoFundMe page. My name is John Gabriel, and this is a new calculus channel. Till next time, goodbye.